So right now the hair is not visible in the scene. We've hidden it before, so let's undo that. I'll select the geometry of the character, and in the particle systems tab I'll press unhide. And as you can see, we have these unexpected results here. The fur is actually standing and not moving. It's in the center, not following our geometry at all. That is due to the order of modifiers in the modifier stack. Right now you can see we have particle system and the armature modifiers here. What we need to do to fix that, we need the armature to be first and then the particle system to be there. If you think about it, it's the geometry changes first and then we grow hair on top of it. If we did it the opposite way, then while skinning we would have to also describe how the bones would affect hair. Not that it's possible, I think it's not, but you get the point. So now we have this hair moving with our geometry, and that is already looking pretty good. So let's have a look at, let's check and see how it looks once rendered. So I'll switch to the rendering tab, make sure that I have the resolution to 50% because I don't need the high quality just yet. My sampling is on preview, and in my case I'm gonna switch the rendering device to GPU just to make it faster. And let's see. So this is how it looks, and we of course had a look at that render results when we were working on the hair in the first place, but I'm thinking to add a small change to that. I want the root to be a little bit thicker now that the character is coming so much closer to the camera. I have that in the settings of the hair, in the cycles hair rendering settings, cycles hair settings, root. Let's increase it to 3. That should be enough. I'm not gonna re-render it right now because we have a more important thing to take care of, and that is hair dynamics. As you can see right now, the hair, even though it's moving with the character, it has no dynamics and in no way is moving like a real hair would. That's because we need to simulate the physics. So I'm gonna stop this playback, and in the particle settings of the hair you can see this checkbox, hair dynamics. I'm gonna collapse the other ones so that you don't see it. Let's turn on hair dynamics, and from that moment on, once you have the checkbox on, if you play back the animation, it doesn't work all the time. Yes, now you can see, even though it's not moving the way we want it to, it is being affected by physics in some way. Let's just get this result. Let's see what this result gives us and work from that. Don't be intimidated by what you see here. This is physics almost never works well from the first attempt. Yeah. So that's not bad in the end, but the rest, I think the hair is a bit too dynamic for the movement of our character. So let's do something about that. And also, as you can see, this hair is going inside the character here, and this is also what we don't want. I'm gonna give this character collision, a modifier in the physics tab. If I turn on collision, And I think I need to do the same here, and the order is important. I'm gonna make it first collider and then add the particle system. And I'm gonna do the same for the flaw. I'm gonna make it a collider, so that hair at least tries to collide with it. So let's have a look at the physics settings of the hair before we fine-tune it. It's not a lot of settings here actually. You can see here is mass, and it's pretty much self-explanatory. The bigger mass makes the bigger mass an object has, the harder it is for it to stop moving or to start moving. That's when if we talk physics, it's not just it's not about heavy hair. It's the inertia that is defining the mass. We have stiffness here, which is a very important parameter, and one that we're gonna use a lot for this one. As you remember, I'm gonna make it recache the physics. The hair going inside the character. It's not only just about it being inside. It's the hair is not stiff enough. The root is not holding it hot enough, and that's why that's happening. So we're gonna increase that parameter. Random is just randomizing the stiffness parameter of each hair, so that it's so there is a little difference between different hair in stiffness, just to get to a more realistic value. What damping is, this parameter is it's basically it slows down the physics just a little bit. In some ways, it slows down the inertia, it slows down the velocities, the speeds. That's also something you might want to, as you can see from our first result, this is what you might want to, this is what is used quite often in simulations. These are the main parameters for the hair dynamics, and the rest of them are the volume parameters. Air drag, as you can see, air has the description here says air has normally some thickness which slows falling things down. Well, and it's pretty much self-explanatory as well. If you want a realistic effect, you need the air drag. You need the air to affect the hair. And by default it's set to 1, and it's pretty good. Internal friction is something that is gonna help you create a feeling of volume, and this is the closest the blender can get to hair-to-hair collision. It's a good parameter, and we're gonna increase good parameter. It's a useful parameter, and we're gonna use it as well. This is the maximum density that the hair can get. That's also helping the hair not collapse on itself sometimes. So the more hair is close to each other, the higher the density of the hair, and you don't want the density to go too high. And that is the strength of density target. This voxel grid cell size is a little bit hard to explain, but basically the Blender is using the technologies from volumetric physics calculations for calculating hair physics, which is a very interesting approach. And basically the lower this value, the better the quality, but we're not going to use this one. There's the one we're going to be using for increasing quality of the simulation is steps, which means it's set to 5. That means that Blender is going to calculate 5 iterations between 2 frames, which is very important, especially when you have fast motion like we have. Sometimes calculating 5 frames between 2 frames or 5 iteration between 2 frames is not even close to being enough if the character has moved up to a meter in that 1 frame or something, or even less. So yeah, that was a very quick lecture on introduction on the parameters of hair dynamics, and now let's use them and let's fine tune it to our taste.